I'm John King here, waiting for my colleague James Ashcroft to get here on his dirt bike. I think he is right there. Oh my gosh, that's quite a beauty right there, that there dirt bike. Oh wow.
I'm James Ashcroft, and this is Science in the Wild.
In this here drop box. I guess we're hunting ourselves in Aubrey. She's a feisty one. Quite ferocious, in fact. There she is now!
There she
is.
Oh
Lord! Hello. I found some wild pizza rolls.
Pizza rolls.
To use to trap our bait. Right. Whatever. Anyway, we're gonna cook them in the microwave, which uses some handed down the electromagnetic waves which transfer the thermal energy into these pizza rolls. I'm putting right there.
Pizza rolls.
Pizza rolls. Alright, this microwave here is using electromagnetic waves to transfer the energy. This is called radiation because it doesn't use a medium. Unlike convection, which this here oven I found out in the wilderness, it uses air to transfer the energy. But that does not. Too hot. Alright, we found Aubrey. She's sitting here eating a wild stash of pizza rolls. They seem very hot because they're transferring the thermal energy to her mouth. It's very dangerous. Alright, this thermal energy here happens when particles move around. It's the average kinetic energy. You know it yourself? Huh?
I found an albino puppy! Look at it! Look at the teeth on that thing! Look at the teeth!
That's got some gnashes.
Oh! I won't want to get in a fight with any of them! Oh, there's a wallaby!
It's a wallaby.
It's a wallaby!
We're continuing our hunt out here for Aubrey. No signs of... Oh, look! It's a wild aborigine!
Aborigine! Everybody knows the aborigines are very rare and very odd. But look, this one's wearing shorts.
She's quite odd.
Because she's wearing shorts because it's very hot and there's no wind.
There's absolutely none.
Because there's no wind because all the thermal energy of the air is all equal. And since it's all equal, it's not
rush around.
It's not rush around
energy.
trying to make it even. So it's out here in its shorts in the heat. Look at that aborigine. Let's get a closer look.
I'm gonna try and poke at it with this
poke at it with the stick.
Aye.
Let's poke at it.
Oh, that's this wild wallaby.
Oh gosh. Oh gosh. It's got a bludgeon. Ah! Ah! It's got a weapon.
Alright, we found some ants right here.
Look at all
They're quite deadly.
So many ants.
I think they'll make a good meal. James, why don't we show them what we're gonna cook them on?
Alright, why don't you just scoop some up on the machete.
Alright.
Look at that.
I think I got some, I don't really quite care.
And we'll cook them on our grill.
Alright, this is actually called the barbie because in Australia. Anyway, we're gonna use the heat from this there sun, which has off radiation, which heats up the air, which gives off convection.
Current.
This here thing, the barbie. And we're gonna use conduction, which transfers the energy from this here barbie directly to what we're cooking through touch. It's going to be quite delicious. Alright, we're on the trail of the wild Aubrey. I think she's over there with a wild wallaby over there. It's quite ferocious.
Drinking some water.
She's drinking water because it's hot out, I think.
Probably. Let's go. Let's go. Let's go. Go. Ready?
Alright, I think we're a bit close enough now. Oh, the wild wallaby's attacking!
Wild wallaby! Wallabies!
Wallaby!
Wallabies! Look at it, it's so ferocious.
We're always trying to...
Alright, so here in our survival kit is our thermometer, which is what they call it in Australia. And a thermometer tells us what the heat is outside.
The temperature to be exact.
The temperature to be exact.
Temperature's how hot or cold something feels.
Yes, it does. So
the average.
It's the average
thermal energy.
Average thermal energy, wherever you are. So it's vary. So that's our survival kit. I feel very safe with our large knives and our thermometer.
Alright, we got ourselves a thermometer here. It's awful hot out here, and I'm sure she's going to know what temperature it is to cook her food and stuff. So we're going to use it as a trap to lure her into this spot. You getting this, cameraman?
Yeah, we're gonna leave it right there.
Alright.
Now let's go hide. Alright, we have our thermometer in place, and we all know how a thermometer works. The air heats up the mercury, which causes the red to rise, telling us on a base scale of how warm it or cold it is. Oh wait, what's that? Here it comes. Oh, is it gonna find it? Oh, it found it. Oh, look at that.
This is a thermometer. Fahrenheit is what Americans use.
Speak up.
Fahrenheit is what Americans use. Celsius is for everywhere else around the world, and Kelvin is for scientists because it's more. Fahrenheit, water freezes at 32 degrees and boils at 212. Celsius, it freezes at 0 and boils at 100. And then Kelvin freezes at 273 and boils at 373.
This film is sponsored by the Coalition for Specific Heat and Absolute Zero.
Absolute zero is the lowest temperature theoretically possible, which the motion of particles that constitutes heat would be minimal. It is zero on the Kelvin scale, and at absolute zero, gases cease to exist.
Specific heat is the amount of energy required to heat 1 gram of material 1 degree. Water has specific heat of 4.186.
Is that for real?
It's for real.
Pizza rolls.
Pizza rolls.
Pizza rolls are delicious.
Hi, it's John King here to explain conductors to you. Conductors are materials that allow the flow of energy very well. This metal here gets quite hot because it conducts the radiation coming off of this here engine. And it does this through conduction, hence it's called a conductor.
I'm Aubrey and I'm the prey. Today we'll be talking about insulators, and this wood is a very good insulator because it does not let energy or heat travel through.
Super happy fun time, yay!